Welcome to the Indian Ocean World podcast.
Hello, and welcome to the Indian Ocean World podcast. My name is Renee Manderville, and I'm the project manager at the Indian Ocean World Center, or IOWC, at McGill University. I am joined by Philip Gooding and Archibald Chowdhury, two postdoctoral fellows at the IOWC.
Hi, Renee. Thank you for having me here again.
Hello, and thank you for having me as well.
Our guest today is Professor Brian Tomaszewski, an associate professor of Geographic Information Science and Technology at the Rochester Institute of Technology in New York. His research relies on intersectionalities of sciences and humanities, covering subjects such as information science and technology, geographic visualization, spatial thinking management, and refugee affairs. His prominent work on geographic information systems, or GIS, a topic which will be elaborated throughout the remainder of this podcast, has recently been used for his project on Refugee GIS, or RefuGIS, in affiliation with the United Nations Refugee Agency. This project maps the journey of displaced peoples and provides navigatory and community building solutions for refugees in search of new homes and NGOs and government agencies attempting to facilitate this process. More information on RefuGIS can be found in his recent publication, How Mapmaking Brings Communities Closer Together, an article that can be found in one of the links below this podcast. Another link provided in the podcast description is Professor Tomaszewski's recent publication on serious GeoGames for disaster resilience and spatial thinking, research which he has been conducting through funding by the U.S. National Science Foundation. While today we will be largely discussing information present in his first edition of his book, Geographic Information Systems for Disaster Management, the second edition of his book is set to be released in the fall of 2020. I'm also going to just mention to our listeners that because Professor Tomaszewski's research on GIS incorporates maps and other mediums of visual data, our audience can also find a video recording of this podcast on our Appraising Risk website. Brian, it's an honor to have you with us today. Thank you so much for agreeing to provide us with some valuable insight regarding GIS in our podcast this morning.
Thanks, everyone. I'm honored to be here.
So first of all, do you mind just introducing Geographic Information Systems, or GIS, to our audience? What are they? How is this data compiled? And what is the intention of collecting this multifaceted form of data with respect to disaster management?
Sure. So when I'm at parties and I tell people what I do, the very lightning fast explanation is, I do maps in computers. And so to try to relate that to things people can understand, it's not, academically, it's not necessarily a complete match, but like things like Google Maps, right? We all have a smartphone nearby. I often tell my students, raise your hands if you use Google Maps at least once a day. Even the three of you, do you think you use Google Maps at least once a day?
Probably, yeah.
Right. Even when you live somewhere, you're always looking things up. So, that's the quick way to explain it. Digital mapping, digital data. However, the ideas behind GIS predate computers. So if you break the word down, Geographic Information System, so that system is a whole comprised of individual parts. So we often think of, sometimes GIS just gets associated with the software. Excuse me, there's a commercially available GIS software that I teach my students how to use. There's open source software. There's things like Google Maps that I've talked about. But that's just one part of it. You also have the data that's fed into that software. You have the people that are using the software. You have the knowledge that goes behind how to use the software, how to work with the data, and so forth. And so from a GIS perspective, that's knowledge of cartography, and that's something, how to make maps certainly is one of the oldest things in human society. I know that what you've told me, this podcast may be of interest to historians. Maps have existed in societies as early as, cuneiform tablets in ancient Mesopotamia. Ancient Egypt, there's vases that have sort of spatial representation, graphical spatial representations are drawn on them, and so forth. So, that's kind of an overview of what the system is behind GIS and how it's used for disaster management. You're going to probably hear me many times in this podcast talk about the spatial aspect of disasters, right? Disasters are things that happen, in places that affect people over time. I'm going to use flooding a lot as an example because I think that's a really straightforward example, but you have to map out the location of water and then try to map out the hazard of that. I know two of you live in Montreal, and I think about the islands in Montreal. It's built on an island. Now, for your podcast listeners, I live in upstate New York on Lake Ontario, and it's not really germane to our podcast, but we have issues with the water levels of Lake Ontario, and they control the level of that lake because they don't want to flood Montreal, right? So mapping that all out is really important. So when, say, the Ottawa River is at a really high stage, they have to block the water in Lake Ontario so the city of Montreal doesn't get flooded. And that's an inherently spatial thing that maps helped us to understand. And you might even consider it a graphical model of the world. That's basically what a map is. It gives us some kind of a representation of the world around us that we can help us to understand things better. So is that a good answer for that question?
A great answer. Wow. So thank you so much. Can you also provide us maybe with a visual example via Zoom screen share of how GIS disaster management is charted, how the map legends kind of relate to one another, or the map?
Sure.
Tell us a little bit about the map legends in general, talk about accessibility and maybe some limitations that continue to exist within this form of GIS disaster management charting.
Thanks for that question, Renee. Sure, I'd be happy to show you some examples of how GIS can relate to disaster management legends and limitations. So with that, let's dive right into it. First off, if you don't mind a little shameless self-promotion, this is the cover of my new book that you mentioned. And a lot of these images are taken right out of the book. And I'll even use some of these images themselves. These are all pictures that I either created or took on my research other than this one in the middle. And I'll explain that in just a minute. So first off, a little conceptual ideas. Disaster management cycle. This is a common way that the idea of disasters are represented. They're often considered, there's variations on this, but the basic idea is that you sort of prepare for a disaster. You might stockpile medical supplies. You might do training on, first aid, and then something happens. Sometimes it's a fast event like a flood. Sometimes it's a slower event like a famine or whatever, but then you respond to it, right? And that can be like, it could go anywhere from calling the fire department to deal with an emergency to a major catastrophe like the Indian Ocean, like the tsunami. I think it was in 2005. I think that's when the great 2004. Excuse me, at the end of 2004, there was a massive catastrophe that affected the whole Indian Ocean world, and so forth. And so once you respond to that, you try to stabilize things. Then you slowly or quickly start to recover. And an example in the U.S. I'll use is Hurricane Katrina. That happened in 2017, and we're still recovering from that. And this isn't necessarily, it's a cycle, and it's not necessarily linear, too. You could still be recovering from an event, and then another one happens. And these things can kind of overlap on top of each other. And then mitigation. This is the idea of trying to prevent things from happening in the first place, like the old saying, disaster by design. And I'm sort of an example of that. I've chosen to live right on the shore of Lake Ontario, so I feel personally that if it floods, I've chosen to live right on the water, right? So a mitigation measure would be to not live on the coast, right? And sometimes on the oceans, they actually pay people to move, to leave a coastal hazard zone. In cities like New York City, there's been a lot of talk of how to build seawalls because of climate change. I'm sure in Montreal, there's all kinds of things they do to try to mitigate against flooding of the St. Lawrence River and so forth. And whether you as private citizens know about that or not, the city thinks about all that. And then the whole thing continues. So you've mitigated, you continually prepare, and so forth. Now you'll see here, geographic information systems, this outer circle is relevant to every part of this model. And in the book, each of these topics get their own chapter in terms of the role of mapping and GIS spatial data. And I'll show you now some graphics to kind of illustrate this. So let's first just look at some different kinds of disasters, right? This is a picture that I took in Amman, Jordan, a few years ago, and this is a classic example of urban flooding, right? You don't think, I mean, if you haven't traveled much in the Middle East, you don't necessarily think of flooding per se as being a real hazard because it's a very dry region. However, in the city of Amman, especially in the wintertime, when it rains, it comes down hard and fast. And you also have the compounded problem of drainage systems are often clogged, and the systems to deal with this are often backed up, and it leads to flooding, right? So how can we, you know, just to start thinking about the role of GIS, how can maps be relevant to planning out drainage networks, how to respond to such an event, and so forth. This is a picture I took in just south of Houston, Texas a few years ago. This is an example of disaster, maybe disaster recovery. Hurricane Katrina came through, and it actually was not necessarily storm surge, it was excessive amounts of rain. So what you're looking at in this picture is a house that's sort of destroyed, and these people need to start recovering and ideally mitigating against future hazards. Obviously, clearly the wall is falling down. You have to really rebuild this house and so forth. This is an image from Hurricane Dorian that I took from, it's called NOAA, the National Oceanic and Atmospheric Administration in the United States. And we will often fly airplanes over disaster zones to collect imagery that is what's called georeferenced. So when you get georeferenced information, you can take this picture and put it into a GIS software, and the picture will know where it is in the real world in terms of latitude and longitude coordinates. So I know that this, on this left, this building that has a tarp on it, where it's located in the real world. And from what you can see, the blue tarp is very commonly used. When buildings have been destroyed, you put a blue tarp over as a quick sort of recovery thing, just to put a cover on your house. It may not be obvious, but these are damaged trees. They're kind of a dark shade from trees, and maybe this was a little woods or something that all fell down. You can see sort of the sand. You can see this building here on the left has the roof completely gone and the exposed interior and so forth. And this is a good example of something like this, what they call, you know, with machine learning, where you could train a GIS to go through and basically identify parts of this image and how they're damaged. So a machine learning algorithm will be able to identify a road that's open, the blue of a blue tarp for a damaged building, brown for downed trees, and so forth. And I think that's a very powerful sort of data science technique that can be used with imagery for disasters. I wanted to steer this back to the Indian Ocean. Last year I was privileged enough, I spent some time in Kerala, which, if you're, you know, familiar with the Indian Ocean world, if not, it's located in southwest India. And from what I learned about going there, it's one of the more economically advantaged states of India. Very tropical, very beautiful. And I visited a part of Kerala where they had been, the land is very low level. And this is a woman in this picture is showing us how high the flood got to her house. And I don't really have a scale. I mean, for all you know, she could be like 3 meters high or something, making a joke. But like, she was probably about 1.5 meters, 5 feet tall. You know, but you can see that the water significantly, came and impacted her house. And I had a really fascinating day. There was a lot of displacement during the flood and so forth. So that's also something to think about. And yes, so that's also something to think about. There is just natural disasters and they impact things, but something I've become more interested in, especially with mapping, is the idea of forced displacement and disasters. And this is a picture I took a few years ago in a refugee camp in Rwanda that has refugees from the Democratic Republic of Congo, which is a country that neighbors Rwanda, and or DRC for short. DRC has had a long geopolitical history of civil wars, And as historians, if you're interested in East African history and you don't really know much about geopolitical context in East Africa, it goes back to the Rwandan genocides and so forth. And those things of the past are very much the context for refugee displacement situations nowadays. But what's interesting in this picture is the slope, because Rwanda just in general physically is a very hilly country. So natural disasters are landslides, flooding, and so forth are an issue here. And now I'll talk about in just a moment. Now we've got coronavirus. We have COVID. Think about COVID in these very close quarters. We were talking offline about our social distancing issues in an urban environment. Think about it in a refugee forced displacement situation where you can't go anywhere. You're already displaced, and so groups like UNHCR, they've been working hard at really keeping coronavirus out of the camps and so forth, because it's, to use the metaphor of a fire, I mean, it's like dry wood waiting for a match to just fall in there, because if coronavirus gets in a place like this, I think that'd be a very, I don't even want to think about it, really. And this is just one relatively small refugee camp. When you think about forced displacement around the world, either long-term, like a refugee, or in the Indian Ocean world, I only really know a little bit about India, but when monsoon season comes, flooding in Kerala, there were thousands and thousands and thousands of people that are being displaced, even if temporarily. And from historians, that I think that's an interesting research topic, is to look back at the history of large-scale disasters. Even, again, I don't know the history, but, what happened before 2004 and back, how did they respond and cope and so forth, okay? So those are just some pictures of examples. Let's look at maps now. So how do you graphically represent these things in maps? This is from chapter 1 of the book. I like to use it. Disaster mapping is not anything new. This is from Hurricane Camille in 1969, and it shows the trajectory of the hurricane as it's approaching. The map starts out showing the line by Cuba, and they're doing sort of a space-time projection, August 14th to August 22nd, 1969, and the hurricane is starting out, as they usually do, out in the Caribbean, and they're, where they're anticipating making landfall, how it's changing from a tropical depression to a tropical storm to an outright hurricane, and so forth. Now, mapping-wise, this is cartography. You have different symbols and shapes to show the trajectory of the hurricane, timestamps, and so forth. So if it's also got things Lambert conformal conic projection. Most people don't really probably care about what that is, but if you get serious about GIS, there's proper ways of using map projections to show data at different scales and so forth. If we fast forward to modern times, this is basically the same way they do it nowadays. This is from a computer-based, a computer-based map that generates hurricane trajectories. This is Hurricane Maria from 2017. It's got a little bit more things going on it, but it's essentially the same as this map in terms of the overall purpose. It just has different ways it's presenting it. Maybe it graphically looks nicer and so forth. It uses colors and so forth. But one of your questions, Renee, was about the legends and so forth. A map like this, though, for some people could be perhaps complicated to read and interpret, especially the legend. So you have to know, day 1 and 3 is sort of the solid symbol. Day 4 and 5 is shown with sort of speckled dots, and that's uncertainty. That's a research topic in cartography. How do you represent uncertainty? We don't know where the hurricane's going to be in 4 to 5 days, so that's why we have the map shows a really wide span with kind of dots just to communicate uncertainty. Hopefully you're not colorblind, that you can read the different colors, hurricane, colorblind for blue and so forth. There's a lot crammed in here, but there's a lot going on. I mean, if you go and get a PhD in cartography, geography, you really learn to break down maps, and they actually are very complex communication devices because people could misinterpret this and so forth. And I'll show examples of one of your questions also, Renee, is about limitations of maps, and I'll talk about that more in just a moment. This is a sort of an official map from the United States. This is a flood advisory map. This is a very complicated map showing where floods potentially can happen at different timescales. In this case, it's around New York City and so forth. And these are regulatory. People base like housing prices and insurance off of official maps. So a takeaway point from this whole podcast, if you've never thought about it, the discourse of maps, the power of maps, right? If an official government document says where you live is within a flood zone, that can impact your insurance, your cost of living, and so forth. We can also do zoning about that. You could potentially lose your house because of maps like this. And that's a big issue in urban, I mean, not just natural disasters, but urban planning and so forth, the spatial discourse of maps and so forth. And so think about that, especially if you live in a city, zoning, planning, neighborhood redevelopment, maps drive the whole entire process, and they have historically. Okay, next up we have a map. This is again back to those, we saw the picture of that refugee camp previously. Now this is what it looks like sort of in terms of the bigger situation on a map. This is a map I created for my book using what's called hotspot mapping. And these are statistically significant areas where conflict events have happened in the DRC. So you can see there's a really big cluster of red points right on the border of Rwanda. And that's what's creating refugees going into Rwanda. And that's the power of maps to look at problems at different scales and to understand bigger regional processes and so forth. This is a map. Again, I wanted to try to put as much Indian Ocean kind of things in it. This is a collage of images and maps from my book about Kerala. And so this is a picture, I don't remember where I got it, but this is what the Kerala flooding looked like. And it kind of ties back into that picture I showed of the woman with her hand showing how high the water got. That's almost the whole entire first floor of a building being flooded. Kerala they were excellent from what I read in their response. They set up a website, and you're seeing more and more of these things of the use of, right there you can see maps is its own sort of pillar of the rescue between requests for help, relief camps, how to give money, contribute, volunteering. Maps are right there, right at the forefront. So you really can't ignore maps anymore in disaster management. You do that at your own risk, at your own, creating your own hazard and vulnerability. And I think of interest to this group, understanding the historical context behind disasters is equally as important. If I'm remembering the Kerala correctly, there was a water reservoir that they actually opened because it was going to burst. And historically, they hadn't opened the water reservoir up since like 1920. But there was so much water building up in it, they had to let some of the water out as a flood mitigation measure. And it did cause some people to be flooded, but it was worse than the bigger issue that would have happened if the whole thing had failed. And so I think those kind of things, looking back at past disasters, how they were dealt with, understanding the historical context, especially as we head into climate change, more intense events, head into it, we're in it already, and so forth, is important. This was from something called HOT, the Humanitarian OpenStreetMap team. And this is the idea now of crowdsourcing, where people were assigned, they basically took Kerala, put a grid over it. I don't know exactly how much each grid area-wise, and people were assigned to look at satellite imagery and do tracing of damage. And this has been a modern technique now of how to gather data sort of free and open source that it can be shared back, and also in a more timely manner. And just to throw another idea out there, this could be an interesting thing for historic maps. If you start to find historic maps, get them digitized and georeferenced. So take a paper map, scan it in, find reference points, put it in GIS. So a map like this could be valuable for crowdsourcing. Historical maps could also be crowdsourced, digitized, and that's a big effort of historical GIS, which I think is part of this bigger Indian Ocean world thing, will be a major outcome of this project, getting a database of historical disaster events that are georeferenced. I think that'll be a major contribution. Here's another sort of official map. This is by what's called the Humanitarian Information Unit, which is part of the U.S. State Department. They're constantly making maps of humanitarian situations. This is one from my book. Again, I just grabbed it. This is looking at refugee situations in Africa and so forth. So again, this is more of a regional level map. You asked me too about legends and reading maps. I think this is an important topic. It's very easy to lie, not necessarily lie with maps maybe, but like how to manipulate information. So these two maps are showing the same data, the same raw observations or facts. The population of people aged 65 to 69 by US county. It's the same data set, but in the top map, I've used what's called equal interval as a way to put the data into bins, right? So if your value is between 2 and 646,059 people, these are just raw counts. That's where you'll get added to a bin. Notice in the map how all of the counties are basically white, or they're in that first legend class. And there's only one on the bottom sort of left in, I'm guessing that's probably San Diego. It really shows, this is good for showing your outliers, right? So as opposed to quantiles, which is a different just method for classifying your data, where you kind of rank it and break it into groups, it's a whole different kind of map, a whole different presentation. Again, the same exact data set, but being able to have sort of a critical eye towards maps and their legends, especially when you're doing quantitative data, I think is very important for people. And that's often a problem with GIS is GIS software is becoming easier to use, but it's easy just to click buttons and make a map and not really understand sort of data classification principles, cartography, color. I mean, this map was specifically made in black and white because that's how my book is being published. So even that I specifically chose to use from white through shades of gray to black to show increase in quantity and so forth. Here's some more far out stuff. This was, you mentioned earlier in the podcast about my serious game. This is now where we have an avatar running around through a real world disaster situation where the person has to go on rescue missions and they read a map. This says the screen is showing deliver medical supplies to the high school. It's on Highway 517, turn left onto Baker Drive. And so you have to read the map, run and make this, do this sort of little mission to help people out. And that's sort of a training thing. And that's an example of using maps for games. This is now COVID. We're living in the world of COVID. This is a map I made of where I live, showing elderly populations. Again, looking at map legends, I even say raw count of population older than 60 years old. I didn't want to get too far, but there's the idea of normalization. And that's an important concept for maps about COVID, comparing people at a normalized scale so you can make real comparisons. So using, say, Canada as an example, comparing Toronto to Kingston. Kingston is where a city I like to go to. There may be more overall cases of COVID in Toronto, but that could just be a fact because there's just more people live there. But if you normalize the data and compare that to another place, then you get a more meaningful kind of analysis of what's happening. I've just got one or two more slides. This is the famous John Hopkins coronavirus dashboard. And this is what you'll hear the media often cites. I took this screenshot yesterday. We're up to 12 million cases around the world. And this is the combination of a geographic map in the main part of the, it's a dashboard like a car. One of my videos talks about how to make much more simple versions of this basic idea though. So you have the map, you have a data graph showing the cumulative number of cases, you have sort of these table things and so forth. I think it'd be very interesting for the Indian Ocean project to do some kind of dashboard for the Indian Ocean on, say, historical disasters, where you could look back at different counts of disasters over time and changing map layers and so forth. To round it out, what I'm showing you now, you asked about limitations, Renee, back earlier before I started talking about all this stuff. I think the biggest limitation is going to be just capacity, right? This is a picture taken from a refugee camp, a different one in Rwanda, from the people that run the camp. Refugee camps are often run by national agencies, and the Rwandans are very good at doing that, but they don't necessarily have direct access to professional GIS software. And I really like this image because they did it on their own. They took Google Earth, they figured out, this case, they wanted to know where their dischargeable latrines are. because it's not maybe the most sexy topic, but health, water, sanitation is a pretty important topic when you have a mass grouping of people. And so they just use Google Earth. They put the locations, they printed it out, they put it in a frame, and this paper map from Google Earth is available in an office. They don't have fancy smartphones, they don't have tablet computers, they don't have web-hosted clouding solutions, they don't have artificial intelligence. I'm just using tech buzzwords, and they probably could benefit from that stuff, but just they use their capacities of what they had, and it's a limitation, yes, but on the other hand, it's not. They're making do with what they have. I like this image a lot too. A lot of people just straight up use an old-fashioned paper map. This is one I found it's called FEMA in the U.S., Federal Emergency Management Agency, where I think these are shelters. Green are open shelters. Yellow, it looks like proposed. I don't know what this acronym is, and red is, closed. And they just put a push pin on the map. And for a lot of people, when you look at the context of people that work in disaster management, a lot of them sometimes are 20, 30-year veterans. They haven't grown up using computers. I think things have changed a lot. In version 1 of my book, when I was doing research, there still was a lot of sort of organizational cultural resistance to using GIS, but I think times are changing and technology in general is more pervasive. So I think you're seeing less of this kind of thing, of paper maps, but it still is a reality for a lot of people. They don't have the capacity, the training. Again, back to the beginning of all this, the system, right? You have to have the computers, you have to have the data, you have to have the people, you have to have the knowledge. And sometimes those things come together in forms like this, just putting a paper map on the wall with push pins. Even as in Katrina, people in Texas where I saw, they were just writing people's phone numbers down on paper. This is sometimes, so think about a developing country or countries in the Indian Ocean where they've made huge progress on these things, but capacity is a big issue. Okay, that is it. I'm now done showing those many slides, and I hope that was useful for illustrating many facets of your question.
I mean, of course it was. I think that you covered a lot of the other questions that we actually had for this podcast pretty thoroughly. So I think I'm actually going to be passing the questioning over to Philip and Argisman right now, because I think you already answered my question.
I think I can ask a related question to that, actually. Does the way you deploy these terms, the way you deploy the transition from disaster, crises, catastrophe, does that change depending on where you look at the world, where you're looking?
I don't think so. I think it's useful in some sense to have, at least in the English language, to have some kind of standardized terms. I guess I'm going right to a very practical versus we could have a theoretical, conceptual discussion about what's the difference between an emergency and a disaster. But I think it's important to use those terms. I mean, again, Indian Ocean, I keep using the 2004 tsunami. That was a catastrophe. That affected a lot of different countries. And when you call something a catastrophe, that gets the world to respond. That gets the United Nations. In my book, I have a whole chapter on international organizations. That gets things like Humanitarian OpenStreetMap going. That gets things like, it's called UNDOC, United Nations Disaster Assessment Teams. That gets UN OCHA, the Office for the Coordination of Humanitarian Affairs. That triggers international mechanisms that are in place, something called the Space Charter on major disasters. So, the way it's probably manifested might be different. When you call something a catastrophe in rural coastal India is probably going to look different on some level than in a low income area of the United States. Sort of, but yes and no. I mean, I've never been directly in the front lines, but poverty is poverty. And even though the United States is a very well-developed country, there are people that live here that I've seen that are in very desperate state of affairs. And they're dealing with a lot of the same issues that people in Africa deal with or people in the Indian Ocean deal with. Even though they are different, there is that the universal human experience. So I think a catastrophe versus a disaster like Kerala, I don't know, when I was there asking people if they were just they didn't want to, I have to always wonder about when you do research, are people, especially I have to be aware of, I'm a white person, a foreigner, when I'm in these places, are they just telling me what I want to hear versus something else? But in Kerala, they were very proud. They were, we were only displaced for a few days. Our local capacities took care of things. I think I don't remember all the details, but there was some outside thing, but they handled it. I mean, I visited the Kerala State Emergency Management Agency. They had a brand new facility with tons of computing capacity, young people. I guess I'm getting older, younger people that working GIS that knew how to use it, were right on top of it. So I would say that was probably more of a disaster. They could handle disasters are large in scale. They probably had to call the Indian, national government, but they were able to pretty much handle it. They didn't necessarily call in. Again, I may be wrong, but I don't believe they called in the UN or other bigger organizations. Things like the Syrian conflict, that's a forced displacement catastrophe. I mean, there's millions and millions and millions of people that have been displaced. They go to Jordan, another country I've worked a lot in. Jordan then has invited UNHCR in to help with the situation. That's a catastrophe. An emergency is more local in scale. Like I said earlier, that's a car accident, a fire in a building. I mean, an emergency could become a disaster and so forth. I think, again, I think the terms are universal. And I think they're useful as an organizational kind of principle, so we know how to respond and how to all the thing in the cycle. How do you prepare, respond, and so forth?
All right, thanks for that. Kind of changing gears here. Talk about something else from your more some very recent work that's come to light recently by you. Look at your YouTube channel, GIS Science, which I actually want to encourage all of our listeners to go and check out. It's a highly valuable tool to further familiarize yourself with GIS data collection and application. And I think it's a really useful learning resource. In those recordings, and you've mentioned it as well just in your presentation just now, you discuss the current coronavirus outbreak in terms of GIS data collection, software management, and interaction between visual interface elements. One of the videos zooms in on current coronavirus statistics collected in India as of late April 2020. Can you, I suppose, comment on this process of data collection, the trends you're noticing, and the disaster management cycle that these India statistics or other coronavirus pandemic statistics may comply with? How do these, I suppose, relate to GIS and the broader methodological issues at play here?
Yeah, let's see where to break that down. That's a big question. I mean, I specifically did that video. We're seeing now India, unfortunately, is becoming close to the top of the list of sort of most affected countries. And also, just I've been noticing on my YouTube channel, there's been a lot of visitors from India. So I really wanted to make a video that was not, even though I'm from the US, I really wanted to make a video that wasn't US centric. And I wanted to make a video that also used open source software, because both of the two videos I've done so far, I want anybody in the world to be able to unlock the power of maps. So if you dig deeper into GIS software, the commercial software is amazing. I use it all the time, but it's got some barriers to it and so forth. In terms of data collection, I think data is out there, but it's still very sort of wild west, to use an American term. It's kind of all over the place. So you have the government of India. I mean, I haven't looked back since I made the video, but you had that one website had an official sort of table of coronavirus data points. And then if you drill into individual states, you may or may not find data. I haven't seen any kind of universal kind of data sharing. I mean, people at Johns Hopkins, they're really focused on collecting data. So by some sense, that's become a de facto sort of standard. But that really ties into a bigger issue of just data standardization for the whole world. I mean, it's a really lofty goal, but there are standards, but is there one central place that you can go and get definitive, authoritative GIS data on anything? I mean, the commercial companies, they publish a lot of stuff, and their data is good, but again, they're a commercial company. Even though they're very benevolent, and I'm, disclaimer, I like commercial GIS companies. They do a lot of good, but you always, I mean, frankly, you have, they're a company. They're motivated to promote their brand, and there's nothing wrong with that. I mean, I do the same thing. I showed my book off, right? So I do the same thing, and so forth. But I think that's going to be an issue. Trends. I mean, I can only really speak on what I'm seeing in the United States. People, I think, are getting fatigued by coronavirus. I think we're tired of being locked up. Again, I'm just speaking from an American perspective. But some of the news, the idea of Americans and this idea we have of our freedom and our individual liberties and all that, people don't want to wear masks. They don't want to be told what to do. And I think you're seeing, like, I'm just going from what I'm seeing in the news. You're seeing outbreaks. I think we're having more coronavirus in the U.S. than ever. It continues to just go on the rise. Now, I live in New York State. I don't live near New York City. New York City was in the news a lot a couple months ago. But other states like Florida and Texas and Arizona, the pandemic is really growing and growing and growing. And even within the U.S., there was issues about just getting data on coronavirus. Like the map that I showed earlier, this one. So the red dots in this map represent coronavirus cases at the zip code level. For your listeners who might not be familiar with the idea of a zip code, a postal code, so the overall shape is what's called a county. I don't know in Canada what the equivalent is. Like, so if you have like Ontario as a province or New York as a state, there must be some kind of sub-level below that. Like we call it a county. Is there something like that in like Ontario or in?
Because we'd call it a riding.
A what?
A riding.
A riding? Okay.
I think we also have counties and general areas, I suppose.
Okay. Yeah. So I've been to Canada a lot, actually. I just don't remember. But so within New York State, you have like 56 or 57 counties. And then within those counties, you have zip codes. So zip codes are a postal space, right? So it's hard. You may not get the sense of it, but let's look. If you look here, that's like probably about 5 miles by 10 miles. My metric conversion, 6 kilometers. 15. Yeah, okay, sorry. I don't mind metric at all. But so you're trying to show all the coronavirus cases at a zip code level when you need to be showing it down at the neighborhood level. You need to know, when we were talking offline, we talked about with one of the podcast hosts about living in an apartment building, right? You need to know on your street block where coronavirus is, because if it comes to your street block, you want to know that because quarantines and isolation. So if you're showing it at that, at least back in April, they were showing it at that scale. So that was one issue. Just to show me that it's at a zip code doesn't really help me. And then these other things are what are called census tracts, all those different shades of blue. That's what the U.S. government uses for tracking population characteristics. Again, Canada might have something similar when they do a census, but census blocks are not the same as zip codes, which are not the same as counties. So you have different spatial units that are for corona are not showing things at spatial resolutions that are useful. So you have to make interpolations and guesses. So the whole thing's a mess. And this is just one county in one state. So standardization, I think that's an issue still, of just a unified data sets that are reliable at scales that match to standardized official data sources like the census. And there was some push on that a few months ago, and that's something to look into. So this is all, back to the Indian Ocean context. I think that's going to be an issue for the bigger project. Data standardized data sets for reporting data, so that if you're looking at India, Bangladesh, whatever countries are involved in the project, you have some kind of standard way they're looked at. And I think Corona is a good example of that kind of thing.
Yeah. Ashwin, do you have questions as well?
I wanted to ask you something about challenges, but you have already dwelt a lot on that. Yeah. But I'm just wondering if you could tell us, where do you see this field going in the future? Because it seems to be rapidly expanding, especially in the context of disasters that you have so well argued and articulated. So I mean, could you tell us how do you see this potentially shifting or influencing disaster management strategies in areas of the Indian Ocean world which are already under severe threat from climate change or environmental crisis?
Yeah, I think in general GIS, I mean the term GIS, I heard an interesting perspective. I mean, what is the shelf life of that term? Again, you guys are historians and you're living in Canada. The guy who coined the term GIS was Roger Tomlinson, who was from Canada, and the term, I think he worked for like, if one of your listeners can correct me if I'm wrong, it was like some kind of like Natural Resources Council of Canada or something like that. And that's where the term comes from. So it's a term from the 1960s. Is it still a relevant term? You're seeing, we talked about Google Maps in the beginning. I think digital mapping in general is becoming more accessible to a wider range of people. Many people don't have a need for all the real specialized things. So I think you're going to still see broader adaptation in it follows computing adaptation in general. So again, you guys are historians. However, computing technology, I remember 10, 15, 20 years ago, a lot of historians were kind of afraid of computers. You all strike me as sort of the younger generation. You've probably grown up with smartphones and working on computers as part of just life. So it's probably not as much of a stretch for you to think about things spatially. I think resources like YouTube, all the open source learning, I think is making understanding GIS more accessible. I think you're going to be seeing more just small screens on phones, tablets. That's a trend that's been going on for a long time in general. And then for the Indian Ocean world, I think it's all about capacity. It's just getting more like what I talk about Kerala a lot because that's just what I know. The Kerala State Emergency Management Agency, they were a really good representative, well-funded state. One of our partners on the project is from the Rochester Institute of Technology in Tamil Nadu state. They have the Center for Disaster Management and Mitigation. They're doing a conference right now. I think just more capacity, getting more computers, more training, more awareness, just people watching, or I still feel like I'm just the advocate for GIS for disaster management. I'm finding the more I go further in my career, I'm less like detail oriented on research, being more just advocate, like use maps for disasters. And if that's all I can leave you with, I've done my job. Like I don't have to necessarily go into statistical significance of hotspots, I know tech stuff, and that stuff's there. But I feel like my purpose now, I have tenure, I'm secure in my career, is just to cast the broader net. Maybe I'm thinking about my own legacy, who knows what, but I mean, I'm not that old yet, but I found that with other professors as they go on in their career and so forth, guiding students along who do more of the detail stuff. So Indian Ocean, I think, I don't remember, this is a very kind of complicated project team. I think outreach that can be done. I think if we get postdocs, and I know with my partners in University of Bonn with Julia Verne, we're bringing a PhD student online. Outreach is going to be really important. She's from India, but she's going to come to the US, come to Germany. She's got to go back to India, do presentations on her data, on her tools, on her methods, doing training. Because I do a lot of work internationally, I think it's so important to give back to the people who give to you, to try to not just take and not give anything back, especially, historical data in India or wherever. I mean, acquiring data, if you scan paper maps in, if you find them, giving that data back and so forth. I think that's going to be really the key, is for the Indian Ocean specifically.
Great.
Okay, well, thank you so much, Professor Tomaszewski, for presenting to us today. It's been a real honor, learning from you. The IOWC has actually relied significantly on GIS for our data management and as a means of effectively communicating with other members of our international partnership. So it's been extremely interesting and illuminating to understand that aspect of our center's research, I think. And so thank you for going into that. And thank you to Philip and to Archesman for their questions. Thank you to our listeners for downloading. And once again, my name is Renee Manderville, and you've been listening to the Indian Ocean World podcast.
The Indian Ocean World podcast would like to acknowledge the generous support of the Social Sciences and Humanities Research Council of Canada. This podcast series is part of the SSHRC-funded partnership project Appraising Risk, Past and Present, interrogating historical data to enhance understanding of environmental crises in the Indian Ocean world.